Well, hi everyone, and greetings from Northern Michigan. This is Bob the Science Guy. For Friday Science this week, I thought I'd do something a little bit different. Rather than doing a video about some scientific experiment, I thought it would be nice just to have a little talk with you, my subscribers. There are some questions that seem to have a lot of different answers out on the internet, and I thought I'd take my crack at maybe doing one of them. Questions like, what is science? What is the scientific method? So why don't we cue up the music and just spend a few minutes together and talk about some things. One of the problems that you run into with science, like many other things, is that it has different meanings to different people. I was once asked what my definition of science was, and after thinking about it for a while, I think I've come up with an answer. It is the systematic and unbiased study of the natural world, which, by using logic and reason, we can use to expand our understanding of the universe. But that's only one part of it. The other part of it is the cumulative knowledge of mankind about our natural world. We have an obligation to understand that cumulative knowledge, expand on it, and leave good questions for our descendants to answer. So let's have a look at this definition that I found on the internet, which I thought was kind of interesting. Science is both a body of knowledge and a process, which is what I just talked about. It's not a collection of static facts. It's a way of actually looking at the natural world to try and understand it better. The other thing is, science always fascinated me. I always thought it was neat that I could predict things based on my understanding of what was going on. Science itself is a very useful thing. We use it in our everyday lives, from our computers and cell phones to the cars we drive to the antibiotics we take when we're sick. The other thing that's interesting about science is, even in my lifetime, I've seen things that science have developed that I didn't have as a child, but I do now. Cell phones, microwave ovens, color TV for that matter. These are all things that we gained from science. I remember how fascinated I was the first time I saw a GPS reading of a location on a map. It just utterly amazed me that with this little box, I could tell where I was on the earth within 4 inches. Science is something that we all, as human beings, can work together to achieve. Science does not understand political borders. It doesn't understand genders or ages. Anybody with a decent telescope and the knowledge to use it properly can discover a new comet or an asteroid or even a planet or a star. Science is an ongoing process. Sometimes people coming in with fresh eyes develop insights into things that the older generations of physicians or scientists had overlooked or become complacent with. There are many examples of this in science. Albert Einstein rocked the world that was very comfortable with Newtonian physics, with his general relativity. After a happy accident in a lab, Fleming had the insight to investigate that mold, and as a result, we developed penicillin. Even technology used to protect England during the Blitz now allows us to make popcorn at will in our kitchens. These are many of the benefits of science and shows that it's an ongoing process. Now, many of us have heard of the scientific method before, either in school or on YouTube videos, etc. What exactly is the scientific method? Well, in many cases, it's presented to us as a series of steps. Now, there are some people that are very particular about the steps that they feel are part of the scientific method and disregard anything that doesn't follow exactly along their steps. Now, if we Google scientific method, we come up with this 6-step series from the Khan Academy. However, if we go over here and we look down a little bit, there's 6 steps. Here are videos and other definitions. And then here's the interesting part right here. What are the 8 steps of the scientific method? What are the 7 steps? What are the 5 steps? If there's one scientific method, why isn't it the same 6 steps? Well, the answer is because the scientific method is not a checklist. So if the scientific method isn't a checklist, what is it? Well, it's exactly what it says. It's a method. It's a process. Now, there are certain phases to the process, and here's a pretty good outline of the approach that the scientific method entails when looking at science. Now, let's go ahead and kind of group these together in phases. The first phase is you have to ask some sort of a question. You have to have something that you're curious about or you want to learn more about. Now, it could be something that's very well understood, such as why is the sky red at sunset? Or it could be something unknown, as Fleming noted when he went to clean out his petri dishes in his lab and noticed that the plates of bacteria were contaminated with a fungus. But looking closer at it, he noticed that there was a clear area of bacteria around each of the little fungal colonies. And that set up a question in his mind. If it was the fungus that was killing the bacteria, what was it about the fungus that was doing that? And that began the investigation that eventually led to the discovery of penicillin. But the interesting thing about it is even with this very broad category of the scientific method, that particular bit of science did not follow it exactly. And that's why these first three boxes are kind of the first phase of the scientific method. The first thing that you need to do is you need to ask a question and then propose an answer to your own question. That's called developing a hypothesis to explain what you see in your question. Now, the hypothesis can be based on a number of things. The first is an extension of pre-existing knowledge. Do we already know something about fungus and bacteria? Do we already know something about light and the sun and have some clues as to why the sky would be red? These are things that we can research. Now, another way that we can formulate a hypothesis is just simply make one up. Tell a story. So, for example, look at Einstein. One of Einstein's great questions was, what would happen if I wrote a beam of light? And then using mathematics and his imagination and insight and knowledge of physics, he formulated an answer to his own question. Now, these are just two ways that we can come up with a hypothesis. There are many more. But in the end, they're all just stories. Until it is, we test them. But that's where the next phase of the scientific method comes into play. For example, we asked ourselves a question, we proposed an answer for it. If we assume that that answer is right, we should be able to use it to make a prediction. So, let's make a prediction based on our proposed answer. Now, the cool thing about making this prediction is that you've got to make a good prediction, one that will give you a yes or a no, depending on what you end up seeing in the next stage, which is test your prediction. Now, you can test your prediction in many ways. For example, you could make an observation. You could do an experiment. You could do a mathematical calculation. You could take a poll of adult females between 35 and 45 years of age with 2 children. These are things that you define based on what your prediction is, and you design the test to give you the best possible answer, either yes or no. And this is the key to designing a good test. You have to have a yes or a no answer. It either matches your prediction or it doesn't match your prediction. So again, the first phase, we ask a question, propose an answer. The second phase is we make a prediction and test that prediction. The third phase is we analyze our test results. And the fourth phase is we come to some sort of a conclusion and win the science fair. But wait, there's more. Before I win the science fair, even though I'm comfortable with my conclusions, I have to convince somebody else. The next step in the scientific method is something called peer review. Now, peer does not mean that it's just somebody that looks like me, that's my age, that's my nationality. The only requirement to be a peer is they need to have some expertise in the subject that I'm addressing. Now, what is their one and only job? Their one and only job is to actually look at my test, my experiment. Is this experiment good enough to give me a yes or a no answer? Is the sample size large enough? Are the results unambiguous? Is there a possibility that those results could be misinterpreted? Is there a way to maybe clarify them a little bit? Let's use a larger sample size. So that's where peer review comes in. Okay, say you make it past peer review and you've got a good experiment that gives you a good yes or a no answer. You've collected your data. You've come to your conclusions. The next thing that you have to do is publish that. And I'll go out and reproduce your experiment. Blue Marble Science will go out and reproduce your experiment. Jaron and Bob Nodell will go out and reproduce your experiment. Actually, they probably won't. But in any event, other people can go out and try your experiment and see if they come up with the same findings you do. Sometimes they don't. Sometimes they do. If they do, that supports your findings. If they don't, you have some explaining to do. Maybe they have another idea of what's going on based on the findings they got. Then you can reproduce their experiments. Well, I think it's about time we go ahead and close up this episode. Now, as you can see, we had this new series started, and what we're going to do is we're going to look at some of the landmark experiments that helped us understand the universe around us. But we're not going to look at it strictly from, well, this is the experiment, this is how they did it, these are their results. That's pretty common. What I'm going to do is I'm going to show how each experiment demonstrated the scientific method in all its forms in action. So I hope that you'll enjoy it. And in the meantime, this is Bob the Science Guy signing out from Northern Michigan. Thank you very much for stopping by and supporting this channel. Remember, we have a Patreon. We also have some memberships. So before we go ahead and hit that like and subscribe button down there and maybe ring that bell icon. In the meantime, take care, and I look forward to seeing you again soon.
Mama, please make them hear me, or I can't teach them anymore. This rabbit hole's too deep for me. Feel my brain getting real sore. Bob the Science Guy. Bob the Science Guy.